Welcome to Section 1. Introduction to Circles, a fundamental geometric shape. A circle, a seemingly simple shape, holds a significant place in the world of geometry. It's defined as a set of all points in a plane that are at a fixed distance, called the radius, from a central point. This unique characteristic gives the circle its perfect symmetry and makes it a cornerstone of numerous geometric concepts. From the wheels of our vehicles to the clock faces we read time from, circles surround us in our daily lives. Their applications extend far beyond our immediate surroundings, playing crucial roles in engineering, architecture, and even art. Understanding the properties of circles, therefore, opens up a world of knowledge and practical applications. One of the most fundamental calculations we can perform on a circle is determining its area. The area of a circle represents the space it occupies within its circumference and is directly related to its radius. To delve into this calculation, we need to first understand how to determine the radius and center of a circle, especially when it's presented on a coordinate plane. Let's embark on this geometrical journey, unraveling the mysteries of circles and mastering the art of calculating their area, a skill that proves invaluable in numerous fields. Our exploration will not only equip us with the knowledge to solve mathematical problems, but also enhance our understanding of the world around us, where circles reign supreme. Moving on to Section 2, Finding the Center and Radius, Deciphering the Circle's Equation. On a coordinate plane, a circle's location and size are defined by its equation. The standard form of a circle's equation is xh squared plus yk squared equals sine r squared. This equation might seem intimidating at first glance, but fear not, it holds the keys to unlocking the circle's secrets, the center's coordinates, and the length of the radius. In this equation, the letters h and k represent the x and y coordinates of the circle's center respectively. The center of the circle, denoted by hk, is the point from which all points on the circle are equidistant. Identifying these values from the equation is the first step towards calculating the circle's area. The letter r in the equation stands for the radius, the constant distance between the center and any point on the circle. The radius is a crucial piece of information, directly influencing the circle's size. By extracting the value of r from the equation, we can move closer to our goal of calculating the circle's area. Let's consider an example to solidify our understanding. Take the equation x2 squared plus y plus 3 squared equals sine 25. By comparing it to the standard form, we can quickly deduce that the center of the circle is at 2 minus 3, and its radius is 5, the square root of 25. With this information in hand, we are well on our way to calculating the circle's area. Now, let's dive into Section 3. Calculating the area pi's role in measuring circles. Having successfully determined the center and radius of our circle, we can now proceed to calculate its area. This is where the mathematical constant pi, takes center stage. Represented by the Greek letter pi, it signifies the ratio of a circle's circumference to its diameter, a value approximately equal to 3.14159. The area of a circle is calculated using the formula area equals sine pi asterisk r squared, where ar represents the radius. This formula elegantly encapsulates the relationship between the circle's area and its radius, with pi acting as the constant of proportionality. Let's revisit our example of the circle with the equation x to 2 squared plus y plus 3 squared equals sine 25. We had determined its radius to be 5. Now, plugging this value into our area formula, we get area equals sine pi asterisk 5 circumflex 2 equals sine 25p. Therefore, the area of this circle is 25p square units. The use of pi in the area formula underscores its importance in geometry and mathematics as a whole. This irrational number, with its never-ending decimal representation, is fundamental to understanding and quantifying the properties of circles. By applying the formula, we can calculate the area of any circle, provided we know its radius. Finally, in Section 4, Practical Applications and Beyond Circles in the Real World, mastering the art of calculating a circle's area is not merely an academic exercise. It holds immense practical value. From engineers designing circular gears to architects planning circular buildings, this skill finds its application in various fields. Even in everyday life, Knowing how to calculate the area of a circular garden or a circular swimming pool proves beneficial. Consider the example of a landscape architect tasked with designing a circular fountain. To determine the quantity of materials required or to estimate the cost of the project, the architect needs to know the fountain's area. This is where the formula we learned, area = pi asterisk r squared, comes in handy. Beyond circles, understanding the principles of area calculation extends to more complex shapes. For instance, a cylinder with its circular bases requires the application of the circle area formula to determine its volume. Similarly, calculating the area of a sector, a portion of a circle, relies on the knowledge of the circle's total area. The journey into the realm of geometry doesn't end with circles. This exploration serves as a stepping stone to understanding more complex shapes and their properties. By grasping the fundamentals of circles, their equations, and the calculation of their areas, we equip ourselves with the tools to tackle more intricate geometric challenges that lie ahead.